Hello everybody, I'm Christian, I'm from TypeFox, and I'm actually quite happy that you all are joining me, and even one more in this very last session of this year's EclipseCon. My talk is classified as other cool stuff, so lean back, make yourself comfortable, enjoy, and let me entertain you a bit. I think so my talk is about code generation for everyone and everywhere, and I guess most of you have an idea what code generation is. My idea about it is basically it's about concatenating string segments with a special attention on readability. And let me introduce this by means of an example. I have brought a TypeScript function named generate module content, and that is supposed to return a string. And it builds this string by concatenating string segments line by line, interleaving line feeds, period. So, looks nice, looks readable. You can imagine how the generated result, the generated code might look like. So what? But there are some problems. And to illustrate them, I have brought another function just called generate module, another TypeScript function. Generate module, also returning a string, but its return value is specified in terms of a JavaScript template expression. These template expressions, let's see how this works. These template expressions start with a leading backtick, and they end with a terminating backtick. It's awesome, isn't it? And in between, they contain static string segments, as well as substitution patterns, and the value of these substitution patterns is usually described by an expression. In this particular example, this method is supposed to generate a piece of JavaScript code, starting with a directive for the runtime, execution runtime, and followed by an anonymous function definition with some body, and the body is contributed by the function we have just seen before on the previous slide. And the body is to be indented by 2 whitespace characters in here. And in order to keep our functions nicely readable and adhere to our coding guidelines probably, I have added some additional whitespace here indicated by these whitespace characters, dots, just for you to distinguish them. What does the runtime do with this? When this code is executed, the template expression, or the runtime, takes the static string segments as well as the substitution expression values and concatenates them in the order they are mentioned in here. So what do we expect these functions to produce? We would like to see some more JavaScript code. Let's start again with our runtime directive. The first line right away at offset 0, first character, followed by the anonymous function definition, also starting at first character. And the body of this function to be indented on each line by 2 characters. And the terminating characters of our function definition shall start right at the beginning again, offset 0. Now let's execute the thing. Too bad the result looks a bit different. My indentation characters are back, but they shouldn't be. I just added them to make my generator function adhere to our coding guidelines and to be readable. But I don't want them to be here. And even worse, the stuff, the body that is contributed by the function from the first slide, which was this one, is mostly not indented at all. And it somehow makes sense because our function from the first slide, it doesn't care about indentation. It was just concatenated just string segments, line feeds, period. So what do we do about this? Option one, we could ignore it and just go with this, but I mean we have here a method calling depth of 2. So imagine we have a bunch of generation functions, each calling them each other, maybe even in a recursive manner. I don't want to imagine how the resulting code might look like. Not readable at all. So just sticking to it is not what I would like to do. Option 2, we could disfeature and torture our generator functions to somehow make them behave and produce the desired result. But then we would violate our coding guidelines, and again, our generator functions readability will probably decrease. Also not a nice option, so option 3, let's try something smart. And there is something that is quite fortunate that JavaScript in this case has not only these classic template expressions, but it has one more thing. It has so-called tagged templates. So I have an idea. Let's use these kind of tagged templates to build our code generator. And these tag templates work in a way that they are quite template expressions as we have seen them, but they are tagged with a so-called tag function. And when the runtime executes them, it executes this tag function, or evaluate them, it executes this tag function with arguments being a list of the static string segments and the substitution values. And this tag function can basically do anything without these arguments. I mean, it could even write it to def null, but this is probably not really constructive. It could produce, again, strings, it could produce objects, it could drop half of it, could do anything. So then maybe let's use such a function to evaluate our template, to check, does this template have some common or each line in this template have some common leading white space we could identify. And if it does, let's strip that one. Furthermore, we have seen that we have here some additional indentation that is not common to all the lines of our template. We could make our tag function smart enough to check what is the value here produced by this one, and all of this is executed at runtime, so we know the concrete values produced by these substitutions. Check them, are they multi-line, and then prepend the indentation on each of these lines. And I can tell you that works. But others had this idea as well. And earlier. And one of them is my colleague and boss, Daniel. He provided this, and his code is still online on GitHub and npm. And I guess others had this idea as well. But still, so question, is this problem solved? Let's see, I still have some questions. Let's think about what happens if this substitution expression here evaluates or expands to nothing, because there is nothing to be generated. do we want to, for instance, keep this additional line break in here that does not belong to the substitution value and that would cause an empty line? Do we want to keep that one? What about this indentation in here? Do we want to keep that even nothing is following? And speaking about nothing, which nothing actually do we mean? Do we mean empty strings? Do we mean non-empty strings with just white space? Do we mean just null? And for the TypeScript folks and JavaScript folks, do we mean undefined? It's not clear. I see some experienced faces here, and they might remember TMF-expand. TMF-expand had a dedicated syntax for tackling this problem. They were able to add a dash character at the end of these substitutions. Unfortunately, we stick here to the JavaScript and TypeScript language. They are fixed, so I cannot just introduce a new character in there. So I have to live with what the language offers me. So this doesn't work here. I have another question, or more even. Oh, come on. We have seen that there's white space in here. So maybe this function developed somewhere else and I would like to reuse it, and they hard-coded these 2 character of white space indentation, but for our project, the code to be generated is to be indented with tabs, maybe, or with 4 new lines, or whatever. What opportunities do I have to deal with this? Going over the result with string search and replace might work, but it's not smart again. I have more things. Imagine our generated code has kind of references to some symbols. Here we have a variable that is to be initialized with a method call, and the method is defined somewhere else, maybe in the runtime code or in other artifacts of our code generator. And for languages like JavaScript or Java or Python or probably C as well, we have to add imports somewhere. And we have to collect these symbols to be imported. And the question is, wouldn't it be cool if we can just do this collection, or just mention them here in the template and the collection somewhere happens in the background? Maybe it's a first world problem, but it would be cool if that would work. And last but not least, we might want to keep track of which portion in the generated code originates in which portion of the source data, assuming that the source data are organized in files with lines and offsets, and you can identify regions within those files. So don't consider the case where the source data come from a database or from somewhere else. My conclusion on this is simply resolving string substitutions and concatenating string segments doesn't cut it. But I have another idea. Let's take, oh, damn it. Let's take the idea of the tag templates, but let the method not produce a string, but something more abstract, something that is annotatable, something that is inspectable later on, and something that is maybe even manipulatable. And let me refer to that like something that is generated. What might something generated be? In the simplest case, it's just again a string. Or it can be something composable, something that is an object, something that can be annotated, and let us call this a generator node. And ultimately, it can just be undefined, and the undefined may denote the nothing I was referring to earlier. And in order to let our function produce now this kind of generated thing, maybe the tag template function, the tag function expand to string is not really suitable. Let's build a new one, expand to a node. And to complete a bit on what is a generator node, we have introduced something that is a composite generator node that just can take, again, has a list of generator nodes, strings, and generator nodes. We have a special one that for capturing indentation information in an abstract manner. And last but not least, we have one that represents line breaks. I've brought an example. What we get when we execute this function and execute this so-called tag template, our function gives us a composite generator node that has a list of contents, an array. And this array then has a string segment for our runtime directive, a new line node for representing the line break in an abstract fashion, next string segment for the beginning of our function definition, another new line node, and then an indent node, determining that the entire stuff that is produced by what's coming up next is to be indented, and the indentation is specified here. And then it can be even configured by some additional data. Let me skip this here. And finally, this indent node is followed by another new line node, which again is followed by our function definition terminating characters. Now coming back to my question, how does this help us for solving this kind of adding a line break or not adding a line break? And again, I would like to try out something, would build a solution or would solve this problem in a smart manner. And the idea now is make our new line node a bit smart. Not solve the issue directly here within these functions, but make the new line node a bit smart and delegate the problem. And this smart, come on. And to make the new line node smart, we introduce a flag called if not empty. Meaning this new line node shall be rendered really into a line feed only if the content up to the previous new line node has some non-white space characters, has something that is not empty. Okay. In case we know that the content before the line feed won't be empty anyway, or we don't want to have it as empty, the flag is set by default. But in case it can be potentially empty, we may set the flag to true. Now the question is, when do we set it to false and when do we set it to true? We set it to false when we know there is content in between, here and here. We would also set it to false if the line is entirely empty, because expand to node shall not swallow empty lines, because we may have them on purpose within our generated code. But in case the line can be empty, there can be content, and in rare cases there is not. And in the cases where no content is, we want to skip the line break. We set it to true. And the rule behind is the following. Expand to node evaluates each line and checks, is there a substitution pattern in there? And if so, have a closer look at the last one. If the value of this last substitution expression is not a string, but it's a generator node, so which is an object, or it's undefined, then set this value to true. If it is a string, potentially the empty string, keep it to false. Now imagine the case, our generate module content function returns undefined, nothing. With this setup, this line break here would render to nothing, so we will have an opening parenthesis, we have a new line, and then we have the closing parenthesis immediately in here. Now imagine a case where we don't want to have this. In case we don't generate JavaScript code, but something specific that is to be interpreted by some other runtime, and it insists on sticking to a strict ordering and a strict spacing of white space and whatever. What can we do? Now that we have this rule, expand to node looks at lines with substitution patterns and checks the last one for being not a string. Then let us add a string there. And this way, with this tweak, we don't add anything to our generated text, but we can influence the configuration of our if not empty setting. And the question is now, maybe we can discuss it later on, do you think there is a means to enforce this flag to be set to true? You can think about, we can discuss later. Now we have these nodes. How do they help us to come to a string? On the slide discloses it already. We need a second step. And the second step is a method that, a method that is called toString and that takes our generated thing and produces as a string. But I had more questions. I had the question about these, I would like to collect symbols in there when I reference something in here. And I said, well, our generator nodes might be something that can be annotated. Cool. I skipped one. Okay, let's get back to that one later. So what you can do is to just write your own tag template, maybe referring to mine. Do whatever you want, annotate your generator nodes. Then of course you need to customize the second step as well. Get out the text and get out whatever you need as well. And process it afterwards. Now let's come back to what I said about the indentation. In case we want to have tabs as indentation, we can enrich our toString method to say, okay, here I give you the default indentation string to be added for each segment that is to be indented. And I can nicely configure it. I can even say I generate one file with tabs and one file with 3 spaces using the same generator templates. And the last one was about, I would like to trace these source and target regions. And we have one solution here as well. We can just even write a third tag template that takes the object, the data, to be to get tracing information, to get source definition information, and then apply our template to this. And this function basically does what expand to node does, plus adding tracing data. So adding adding data where this guy here is defined. And of course, at the end, we again need to gather this one and query it and evaluate it and do whatever we need to do with it. In the title of my talk, I said, well, I stated code generation for everyone. I mean, I was quite JavaScript-centric here. Can it really seriously be for everyone? Maybe I need to do a restriction on that. Maybe it's only for those that are not too scared of JavaScript. But those that are not can just install Node.js, exec npm install Langium, because this is where the implementation of the function is currently located, and start generating. And this is what I would like to just show or demonstrate for now, that it is working. Come on. So I have here an empty directory. I say npm Langium. Takes 5 seconds, 4 seconds, cool. And then I have here my code generation instruction from the slide. I just paste it. I can say, okay, maybe this is boring, because I can also say generator. And I can run it, and then I have my generated code here. On the console, I can write it to a file, of course, with this smart indentation handling and all the other features. And to prove this, we can run this once more, and I can even say add more indentation in here. And again, now we see the common indentation is basically this one. So my second line ends up at offset 0, and the first line gets additional indentation. Back to the slide. The next statement was like, everywhere? Really? Okay, for CLI apps, we just have seen it. For backend parts, it's working as well, trust me. A very important application for me is during unit tests. And I have brought one here. So instead of having several expect statements, testing criterion, and if one fails, you really have to debug to understand why is the test again failing. What you could just do is to convert with this function. N is abbreviation of expand to node, S is an abbreviation of expand to string. You could just take your result that your test had produced, convert it to a human readable string, readability again, and compare it to some string that you expect. And the additional advantage on this is, even if something fails, if your test expectations are not met, you can even encode a human understandable, a human readable error message. So what actually had happened, and not true unequal to false. So I very strictly seriously suggest this kind of assumption testing to you guys. Works in Java the same. In my production project, I very often use this. And where else can we use it? In front end? Really? Let's see. So I have a little demo project, a website with a Monaco editor, with a language server, implementing an example language we have in the Langium project, and some example input, which is a price calculation just for demo purposes. And no, I want to see the result. Here we have some result value, and I don't want to pause for now. So if we change some values here, our calculator calculates a new result. And for demo purposes, it does that by generating code actually. So I activate my breakpoint, go in here, have my object that the Langium language server provided to me, and I just go into my generator functions, go into expander node, go into the nested function call, generate some stuff. Here now we see in the value field we see the composite generator node just representing the body code. Let's go out, and once we have now all the substitutions, we can go in here. Then the expand to node function check function is executed with the static code generator part. Show me here, and the substitution, which is just our generator node. And let's go out of here. And now we have here our text that is generated. And let's get out of here. And now I do for the demo window.eval, and then the code is executed. And I stop for here. I continue in a second. So front-end parts work as well. Surprise. What else can we do? I was speaking repeatedly about these keeping track of source and target regions. If we have this information, we could empower our IDE to say, okay, I have this, come on. I have source code, I have generated code, and when I click somewhere in the generator code, I can build a feature like go to DSL source. Same way, other way around, I could build a feature like I have here the source definition, show me what is the corresponding generator code. Nothing super surprising. The Xtex folks added this in the past already to the extend language. I think others have it as well. But this is just only for browsing. And now there comes the really cool stuff. We can also use it during really executing and debugging our code. And for this, I go back to my editor, and this is why I stopped here. We can use this tracing information, this tracing information to build, in the JavaScript case, to build JavaScript source maps. And this is what has been done within here. So when I do one more step, the browser loads the text, loads the source map file, and gives me directly my DSL source. I mean, this is basically the same, not basically, this is the same than what we see in here. For now, I need to step out once more because the code just contributed a function, and we need to execute this function finally. And now I can step through my DSL code. I can have a look here at the variables that are defined. Material per unit is the first one, and it will be assigned one by one. I can check the value just by hovering over the variable name within the DSL text, and can even put a breakpoint point in here, continue stepping until this one. This is a function definition actually. Again, the function is defined, and now the function is called, and I even see the variable, the argument values here. And now I have a result. So we did the showtime. So how to get this? I've showed it already. Instead of just using expand to node, we just use the tracing aware version. Same thing here. And then there's a library for the JavaScript case to support in generating these source maps. And based on this, we can generate these data that we have seen. This source tracing information stuff works for Langium AST data, so basically data that has been produced by the Langium parser. Alternatively, you can get JavaScript objects. You can put JavaScript objects in here when you have cases without Langium. And for more details on this, visit the blog that I've written a couple of weeks ago. And that's it. Thank you for listening, and are there any questions? Otherwise, I would wish you safe travels and would love to see you next year again, wherever it may be. Happy generating!